Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for MCF 3M students who are working on the summative. From the practice questions in preparation for the summative, this is question number 2. The question says, a rocket is launched into the air from a platform. The height of the rocket in meters, t seconds after being launched, is given by this equation. And then there's some questions I have to answer. How long is the rocket in the air? What is the maximum height reached by the rocket? And how long does it take to reach maximum height? So, first thing I always like to do is look carefully at the formula given to me and make sure I understand all the variables. So this is a formula that's comparing the height of a rocket in meters with the time since it was launched. Now, as soon as I hear about the height of a rocket, this picture comes to mind. It's a projectile. We shoot it up in the air and it comes back down. Now, I don't know any of the values on this picture, but that's a good thing to keep in mind whenever you're working with a projectile question like this one. So we know that we are dealing with height versus time. Now, the next thing I'm going to do is look at how the equation was given to me. So this equation, or this formula, is obviously a quadratic, because if I were to multiply stuff, I would eventually see t squared, and nothing more complex than t squared. That makes it quadratic. And then the format it's given to me right now, it's in factored form. So I'm going to think about all the things that I can do easily with factored form and try to do them without doing too much more complicated algebra. So factored form, our favorite thing to do in factored form is to find the roots. So keep that in mind. So let's now that we understand that we have a quadratic in factored form and it's comparing time versus height for a projectile, let's look specifically at parts A, B, and C and see what we're supposed to do. So part A says, how long is the rocket in the air? So we have a rocket, and I don't know where it starts from, so I'll just go do this. There's my rocket. So when it says how long is it in the air, it's asking me about time. So how long is a question about time, especially because this is only either height or time. So it's clearly not height, it's time. So I need to find time. And I need to find the amount of time that the rocket is flying through the air. In other words, it was launched here, flies in the air, reaches its maximum, and then falls back to Earth. So I want to find out when it falls back to Earth. In other words, what time does this happen? And the time that it happens, well, that is one of my roots. It's an x-intercept. So by finding an x-intercept, I'll be able to find how long it took for the rocket to be thrust up into the air and then come back down. So to answer this question, I need to look at the roots of this equation, or the x-intercepts. That'll tell me how long it's in the air. The next part says, what is the maximum height reached by the rocket? So again, here's my projectile, maximum height. We know that anytime we see the word maximum, or sometimes minimum, in a quadratic, we know that this is saying, hey, find some vertex information. So the maximum height is the height that occurs at the vertex. So how do we find the vertex from a factored quadratic? Well, the easiest thing to do if it's factored is to find the roots. And of course, we already would have found the roots in question A. Once you have the roots will be perfectly symmetrical around the axis of symmetry, which means that if I find the midpoint of the roots, I'm finding the x-coordinate of my vertex. So once you have the roots, which are very easy to find in a factored quadratic, we want to find the midpoint, not midpoint, of the roots. Because when you have the midpoint of the roots, you have the x-coordinate of your vertex, and then you just need to find the y-coordinate, or in this case, the height coordinate. To find that, we sub that midpoint back into the equation. So we would sub back in here. Once we find the t midpoint, not x technically, we can sub it back in, do a bunch of math, and solve for height. So that's how we find the vertex from a factored equation. We find the roots, find the midpoint of the roots, that gives us the first coordinate of the vertex, and then take that value, subbing it back into the equation, and that'll calculate out to give us the maximum, or the rest of the vertex. And then the next question says, how long does it take to reach maximum height? Oh, well, we would have already found this answer when we did part B, because when I know the vertex, In this case, the vertex would be t comma height, because usually it's x comma y, and the x would be where the t is. So that's how I know the vertex will be time and height. So once I know the maximum height, which I will have found already in part B, all I have to do is look here in my vertex and tell you how long it takes to get there. And of course that number will be that midpoint of the roots number that we found. So question C won't take us very long once we do question B. And that's it. So what I want you to do is, the video is not over, but I suggest that you pause the video and do this question right now by yourself. So I've given you sort of the advice and suggestions on what approach to take. So now take pencil, take paper, take your calculator, and actually try this question now that you have a better idea about how to approach it. And then when you're done, unpause the video and compare your answers with mine. So how long is the rocket in the air? So the rocket is in the air until it hits the ground. And when it hits the ground, well, the ground is a height of 0. It's called ground level for a reason. So we're going to let the height be 0 and then figure out what time it takes to get to a height of 0. So now that I have 0 over here, I remember why I really like factored quadratics. Because what I have on the right side is I have -4 times t plus 2 times t minus 8. Now, if any one of these three things, so this bracket, or this bracket, if any one of them was equal to 0, the whole expression is 0, because 0 times anything is 0. So if I can figure out what values of t make any of these brackets 0, I've got a solution to this problem. Now, obviously, I can't make the first bracket -4 0, because there's no t in it. -4 is always -4. But here, I can make that bracket 0 if I let t equal -2. So if I let t equal -2, this whole bracket is 0. 0 times -4 times whatever that is, -20, is still 0. So t equals -2 would give me a height of 0. Now there's another bracket here, and the same idea. If I make that bracket equal to 0, which would happen if t was 18, if this bracket's 0, then 0 times whatever, doesn't matter what it's happening when I'm multiplying by 0, 0 times anything is 0. So those are the roots of this quadratic. Now let's actually interpret our answer though. How long is the rocket in the air? Is it in the air for -2 seconds or 18 seconds? Well, hopefully, pretty obviously, this doesn't make any sense. It's in the air for -2 seconds. We're not trying to build a time machine here. So my answer would be that it's in the air for 18 seconds. But let me just make sure that you understand why we get the two answers. The reality is that the rocket must be doing something like this. Now, this route here is at 18 seconds. Now, the rocket must have started slightly above ground because there's an imaginary route over here at -2, because remember, every single quadratic is perfectly symmetrical. So there's a route here at 18 and there's an imaginary route here at -2. Now, obviously, my answer was 18 because that's when it hits the ground. It's not a time-traveling alternate universe rocket. So after 18 seconds, which is one of our routes. Second part of the question says, what is the maximum height reached by the vertex? Sorry, by the rocket. I gave it away. So we know that we are looking for vertex when we're asked for maximum. And in factored form, the easiest way to find vertex is to find the roots and use them. Now, we already found the roots. We found them in the first question. The roots were the values that made this bracket 0 and made this bracket 0. So -2 and 18. Now, if we find the midpoint of the roots, so -2, add 18, divided by 2, I'll have 8. So it's also like finding the average. So exactly halfway between these two roots is 8 seconds. Yeah, to go back here quickly to my picture, here's my roots, and I was sort of drawing that midpoint anyway. That midpoint represents, it's 8, don't forget, represents where the axis of symmetry is, and of course the axis of symmetry always passes through the vertex. And so that means just by finding, oops, wrong way, just by finding the midpoint of the roots, I know that my vertex is 8 comma something. Now, how do I figure out what that other part is? Well, if I know that t is 8, I can simply sub it in where t is in the equation and then calculate what the height would be. So the height at 8 seconds is, there we go, -4 times t minus 2 and t minus 8t. So I always substitute in a bracket, so I know it looks a little more messy, but it's because I'm using a tablet. So I have -4, and then this bracket is just 8 minus 2, and this bracket is 8 minus 18. And then I just calculate what this is. So -4 times 6 times -10 is 240. So my vertex is at 8 comma 240. What did I do wrong? Aha! I just found my error. I copied something wrong, and I knew I was wrong because I'd already done this work in advance. Oops. This was 8 plus 2. 8 plus 2 is 10. So, there is nothing wrong with making a mistake. I mean, if no one made mistakes, no one would ever figure anything out. Okay, so -4 times 10 times -10 is 400. So that means that the vertex is 8 comma 400, and therefore the maximum height is 8. No, that's the t value. This is the height value. So the maximum height is 400 meters. And then let's move on to the next question, because we've already answered it. How long does it take to reach the maximum height? So remember, we already know that the vertex is right here. And the vertex is t and h. So the height at the maximum is 400. So the time to get to maximum must be 8. So the answer is 8 seconds. So answering C, very easy, because we needed the answer to C to do B, which came first. So I hope that was helpful. Again, really importantly that you understand sort of the thinking process behind how to get an answer like this based on a projectile motion in factored form. Happy studying.